Hello everybody. Welcome to this chapter Electrical System for Onboard Diagnostics. In this chapter, the first lesson is Automotive Electrical System for Onboard Diagnostics and a detailed breakdown. So to proceed further, the Automotive Electric System for Onboard Diagnostics. The Automotive Electrical System is the foundation that enables onboard diagnostics to function effectively. It powers the sensors, control units, communication networks, diagnostic interfaces that monitor and report vehicle health. Let's explore how this system is structured and why it's essential for diagnostics. All right. Now, the first and foremost thing is the core components of electrical system. What are the core components in electrical system of a automobile? The first thing is as component is battery. The role of battery is to supply power to ECUs, sensors, even when engine is off. Now, this is a common knowledge or rather common sense. So, the role of battery is to supply power. Next is alternator. Charges the battery and powers electrical system while driving. Okay, so this recharges the battery as the vehicle is driving. Next, coming to the fuses and relays, it protects circuits and control power distribution. Okay, so it protects the circuits and control power distribution. Next is wiring harness. This is the equipment which connects the sensors, actuators, control units, etc., etc. Now coming to the grounding system, it ensures stable voltage and signal integrity. Now talking about the second important division or vertical of onboard diagnostic, it is the electronic control unit. Electronic control units are microcontrollers that manage specific vehicle functions. For example, engine, transmission, brakes, telematics, ADAS. Or for every vehicle function, there is a separate ECU in the modern cars. The next important electronic power control unit is power train control module, and it is the central unit for OBD. Now, when it comes to ECUs, they collect the data from sensors, generate diagnostic trouble codes when faults are detected. All right. So the purpose of the ECU is to collect the data from the various sensors and generate or dispose the diagnostic trouble codes when the faults are detected. So understand this role carefully, and we'll be discussing about diagnostic trouble codes in very elaborate manner in the coming chapters. Now, when it comes to sensor network, what are the various sensors? OBD relies on vast array of sensors to monitor vehicle performance. For example, oxygen sensors, it tracks the exhaust gases for emission control. Mass airflow sensor, it measures the air entering the engine. Throttle position sensor, it detects the accelerate input. Now, anybody who has a decent knowledge of IC engines knows the purpose of each and every sensor which I mentioned here. Now, coming to the coolant temperature sensor, it monitors engine temperature. NOx sensor, it detects the abnormal combustion. Okay, so these are all the various sensors that are a part of the IC engine, and these sensors send analog or digital signals to ECU, which interpret the data for diagnostics. Now, when it comes to communication protocols and networks, the modern vehicles use serial communication protocols to transmit diagnostic data. Okay, now control area network, most common protocol, fast and reliable. Next network important communication protocol is local area network, used for low speed subsystems like windows and mirrors. Next important communication protocol is FlexRay and Ethernet. Now this is a very upcoming protocol. Nowadays this Ethernet is almost replacing CAN and LIN, because many OEMs or many tier 1 companies are finding that Ethernet is a very robust communication protocol. Okay, this is found, that is why the reason why it is found in high-end vehicles for ADAS and infotainment systems. These networks allow ECUs to share data and coordinate diagnostics across the systems. All right, so these are the various types of protocols that are used in automobiles. Now coming to the diagnostic interface, the most important interface is the OBD-II port, and I'll be explaining about this OBD-II connector. There's a separate chapter for this, but for now you understand that this OBD port is located right under the dashboard, and the OBD connector is a 16-pin interface standardized by SAE J1962, And when it comes to pins, key pins is pin 4 and 5, which is connected to the ground, pin 16, which is connected to the battery power, pin 6 and 14, which is connected to the CAN high and CAN low, pin 7 and 15, K line, ISO 91412 and KWP keyword protocol 2000. Now, having said that, this is a usual. This is not a hard and fast rule. This is not a 100% correct rule. Sometimes this configuration may change, but this is the most widely used configuration for various kinds of connections. Okay, now when it comes to software and diagnostic modes, the OBD systems support various diagnostic services, which is mode 01, real-time data, RPM, speed, fuel trim. And when it comes to mode 03, retrieve stored DTCs, mode 04, clear DTCs and reset the malfunction indicator lamp, and mode 09, vehicle information, like vehicle VIN, the vehicle integration information number, calibration ID, etc. And these modes are accessed via CAN tools or diagnostic softwares. So, and last but not the least, the most important electrical vertical is power management and voltage stability. Diagnostic requires stable voltage levels to ensure accurate sensor readings. Voltage fluctuations can cause fault DTCs or communication errors, and systems like voltage regulators and capacitors, they help maintain consistency. Okay, now, so to conclude, the electrical backbone of diagnostics, to conclude the electrical backbone of diagnostics, the automotive electrical system is the lifeline of onboard diagnostics. It powers and connects every component involved in fault detection, performance monitoring, emissions control. And without a robust, underline this word, without a very robust and efficient electrical architecture, OBD systems would be unreliable or non-functional. Now, this sentence is non-negotiable. Without a robust electrical architecture, OBD systems would be unreliable and non-functional. So, hope all of you get an idea about the importance of electrical architecture. Okay, thank you.